Hello students. Next method of GVF computations is graphical integration method. Okay. This method is useful for prismatic as well as non-prismatic channels and generally used for natural channels, that means non-prismatic channels. The limitation of the earlier method was that it can be used only for prismatic channels. Okay, the direct step method. Okay, now see this graphical integration method. So dy by dx is equals to s naught minus sf upon 1 minus q square t upon ga cube. This formula we have derived for uh, as a dynamic equation of GVF in our classroom as well, or it is available in many of the texts. So this is a well-known formula. dy is equals to dy by dx is equals to 1 minus s naught minus sf square upon 1 s naught minus sf upon 1 minus q square t upon ga cube. Okay, next, for given q and channel shape a, t and sf are the functions of depth of flow y only. So here, if q is a constant and a is a constant, then t and sf are the functions of y only. Simple statement. So we can write dy as function of dx as function of dy only. Okay, so function of y is equals to 1 minus q square t upon ga cube into the bracket whole divided by s naught minus sf. Next, integrating the above equation between two sections which are at x1 and x2 distance from the control section, and where the depth of flow are y1 and y2 are. So we will be integrating this dx and this. So x is equals to x2 minus x1, x2 minus x1. Okay, is this it? X2 minus x1 is equals to integral y1 to y2 f of y dy. So f of y is actually this 1 minus q square t minus ga cube upon s naught minus sf. Okay, next, actually from here the trial and error starts. Various values of y are assumed and corresponding values of f of y, that is 1 minus q square t upon ga cube whole divided by s naught minus sf are calculated. Okay, from these values a graph of y against f of y is drawn. Okay, the area under this curve between y is equals to y1 to y2 is then measured. So the curve is like this, GVF profile. Okay, y1 to y2, this is length of curve y1 to y2, this is x2. Okay, so this is f of y1, f of y2. Okay, now this area represents x2 minus x1, that is length of curve. If y1 and y2 are close to each other, then x2 minus x1 we can find it this way, f of y1 plus f of y2 by 2 into y2 minus y1.